Low output could be a weak tube. You know, output tubes tend to get weak. So tube testing is next. The amplification in the radio. Let's double check when we have a chance before I blow it up. 410L 52763 52763 4120, right? 33, yep. C 960, so right around this 1,000 here. Ooh, it's a little low. Remember I mentioned this is the guy who's mostly responsible for the amplification in the radio, and the radio's output is weak. So I'm going to get another 12 BA6. But first, let's test the last two. I'm just skipping the rectifier two. So this should be a 12 BE6, I think. 12 BE6. 12 BE6. Bear with me while I set this guy up. 4 8 L 51763. 12 BE6 51763. 51763. 3,000 on the bottom. 3,000. 41. C. There we go. What's it say here? It says 1570 is the reading we should be looking for. That's way up in this range, up here. Whole tube heptode. Whole tube. I don't think it's a two-part tube. Why would it say whole tube? Sometimes you have a two-part tube and it tests them together. It says whole tube when it does that. Well, I'll have to take that back. A 12BE6. 12BE6 is a two-part tube. One test for the whole thing. That's what this is saying. Okay. And 1570. Wow. Right over to there. So this guy goes back in the radio for sure. We find a new 12BA6. And hey, maybe I've got one right in this tube box here. I may. Let's take a look. As soon as I can figure out how to plug this tube back in over here. What's going on? There we go. Huh, where's my box of tubes? BE6, well, BA6 right here. I bet you this is a brand new tube. A quality product. Canadian General Electric, Toronto. It's brand new. 12B. Oh, this is 12. Yeah, 12BA6. That's good. That's what it's supposed to say. Good job. And we gotta go back here. Now I've got tons and tons of 12BA6s, you know, loose, not in boxes. So it's a little odd that I should have pull one out of a box. But brand new. This is not ultimately going into this radio. This brand new one is headed for one of my radios. He says very defiantly, 12BA6. So we got to set this back now. 410L. 52763 52763 4120 4120 33. Because you've watched me do this, I don't have to double check, because if you're keeping an eye on me, I know that. Ready? Ready. So this would be an NOS tube, no new old stock. But really, it's as good as new. I'm sure. Shorts. So again, this guy is supposed to read about 1,000, right around 1,000. Oh! Okay, so maybe I've got a setting wrong. Let's just double check it here. That happens. 52763. 52763. I'm gonna be dead out of the box. 4120, 4120. Uh-oh, everything's right. Sensitivity 33. Wow. Let's see. Wow. Who'd have thought? I was really hoping it would come up here. New in a box. That shows you. I'm going to have to go dig some more up because I'm not sure I have another one in this particular somewhat random set of tubes I have here. Yeah, I got to go off and search. Okay, I'll be back with like a bag of them or something. Okay, let's go wild here. 12 BA6. I always like to double check just before they were at 12 BA6. Ooh, see the heater just flash up on that guy. So these are not necessarily new. They're probably used. I don't really know what the story is. There we are. That's what we're looking for. There's a good one there. I might as well, I have two more. I might as well test them quickly in case I need to discard one of them. Oh, that jumped. This is actually what you're supposed to do with a tube when you do this test, but I don't know why you're supposed to whack it. I don't know. I don't know what happened there. Oh, she's going nowhere. Let's just double check a few things here. Yeah, it's going nowhere. Is it really a 12BA6, he says? Having always claimed to check it. Yes, it's a 12BA6, but I think it's heading for the garbage. That's where this one will go. What I do is I bend the pin down on it, so that's how I know if it does manage to get back in my collection that I tested it and it's a dud. I can leave it right here on the last one. Oh, another one with the same kind of short. There's something special about some of these tubes. You know, there's that weird note on the on here. Where was that note? There's another radio I'm thinking of. I'm doing too many radios at once here. Well, I don't see any weird note here. Okay. Who knows? So we test it anyway, because we tested the other one. It shows up good. Strange about the pin. Okay, so this one did not show a short, but it showed a really good. This is the one that put in the radio. Quick. Over to the radio. In you go. Now we should have a good set of tubes in here. This one may make a big difference. Volume down. Power on. Gave it the full shot right away. Yeah, I'm not going to use this 12BA6 in the radio I was thinking of, because the radio I was thinking of uses 6 volts for the heaters, so I can't put a 12 in. Okay, Mr. Radio, here we go. Well, it's just not coming through, is it? It's not showing up. Mr. Radio, you are not showing up. Well, what to do now? Well, we should listen to the signal at the top of the volume control, where it first comes out of the radio. Short power cords, a bit of a problem. So, volume control is here, and let me just check on the schematic. These are not all done exactly the same, but usually the volume control, one side is tied to ground. So this is B minus, or the ground, tied right onto one end, and the other end, of course, has what's coming out of the radio, basically out of the detector. You can put it that way. So we need to listen to that. So to listen to it, here comes the signal tracer. You know what? This is almost like the cone of silence on Get Smart. No, Jim, not the signal tracer. Yes, it's required at this point. Nothing nervous about that. So we'll set the signal tracer for audio. If I get a reply, I would worry. So, I'm not sure if this is the ground one or not. This would be pretty loud coming out of the radio, I would think. Let's try the. So the volume's up full. Let's see what's on the volume slider. Nothing much. I gotta tune the radio. This is a big problem. This is a big problem how I have this. I gotta flip it right over, I think. I like having these hot tubes right at the top, though. I have to get the wheel off the. Just do this. I have to get the tuning wheel off the bench here. Holding up a live chassis, danger everywhere. Oh, that's really crappy too. Okay, I think I can stabilize it fairly easily. Stabilize it with a cardboard box. There we go. Now, what do I have to do here? I want to tune something in, that's what I want to do. The voice would be better. Oh, it's so quiet. Oh, was that another shot speaker? No, I wouldn't think so. Not speaking to me. Well, we'll have to go with this noise. It's so quiet. So on the volume control, we should hear the same noise. Top of the volume control should be, let's see, the volume's right up, so it should sound the same. That's the bottom end. That's the grounded end. The other end would be in the dark here. So that was the top of the volume control and the slider. They have the same volume on them. So that tells us what's coming out of the radio is what we're hearing. I don't think there's any problem with the audio side of this radio. I don't think. Hard to tell because I can control the amplification off of this and boost it way beyond what the radio might do. Get false impressions that way. So another thing we can do is we can listen to what's happening right at the front end of the radio. We would like to know what is getting on the grid of the very first tube. Here, the grid is pin 7, or top of the capacitor too. Pin 7 on the 12 AT6. No, on the 12 BE6. Pin 7 on the 12 BE6. It's really buried. Pin 7 looks like this. Really? I don't think that's pin 7. Because, oh look, there's a voltage chart here. I missed that. Hey, let's try that. That's more basic than what I'm doing now. Okay, so starting with which tube you want to start with? Let's start with the output tube. So let's say all readings are taken where DC voltages are measured with a 20,000 ohm per volt. That's a pretty good meter. And so it's all AC voltage measured with 1,000. Indicates a measure with a VTVM. Well, that's okay. This is as good as a VTVM, really. All voltage is measured between socket terminals and B minus. B minus, volume controlled, minimum position, gang closed, no signal. Well, we're going to look at DC voltage. I'm not sure that's going to matter too much, but so B minus, the easiest way to find B minus is going to be looking at the big capacitors there, and the negative is B minus. That's about the safest place to go and get a hold of that. Or easiest place to go. So the negative part quite certain it's right here. Okay, I'll go on the negative lead. Meter. Now we're ready to go. Okay, 50B5, this tube here. Pin number 1 is 0, or number, 1, 2, 3. You want to do really 5, 6. 5 and 6 are the two key ones. 5 and 6. So 8. 7, I counted something wrong before. 7, 6, 5 and 6. Here we go. 6. Oh, hold still. Six is 90. Should be 79. And 5. .138 should be 128, so everything's a little high. That's okay. So that's it for that tube. Next tube we should find. The next tube is the detector tube. There's no real. Oh yeah, there it is. 132 on pin 7. Never mind what I was going to say there. 132 on pin 7. So pin 7, this is the rectifier tube. I'd say this is pin 7 here. 143. So, we're ahead in the game. I don't think that's a problem in itself. A little extra B plus. Next tube we will do is 1286. We should find 36 volts on pin 7 of the 1286. We can get at it. Oh my gosh. It's just all buried right under here. I don't know. What else is on the 1286? 36. 36 on pin 7. That's all I got to do is hit pin 7. I can do it. I'm sure I can do it here. Wow. Wow, it's just about impossible to get at, I think. Really cannot stick a probe up there. So if we're talking about pin 7, and then we're talking about pin 7, it's the plate. So it should be easy to find this. And a resistor. Yeah, right. Yeah. So this capacitor and resistor can all be contained in that little circuit. Well, I have a tube extender. We could attempt this with a tube extender on the top. Let's skip that one. Just too much trouble to get at it. 12BA6. 12BA6. So. Okay, on the BA6, which is easy to get at, look at pin 6 should be 79 volts. I think this is 6. 93. And that's it. Oh, same thing on pin 5. Not quite the same thing, but it's supposed to be the same thing. 79, 79. Why would they be different if they're supposed to be identical? That's interesting. 12BA6. Pin 6 and pin 5. 6 and pin 5. So it's a screen and plate. Oh, is that a funny little deal in there? According to the book, this should result in the same voltages here, but it's not. Pin shield in tube socket. In tube socket. I just don't know what that means. Okay, on to the next one. The same thing again, 79, 79. The rest of them don't matter that much. So last tube. That was 6. Yikes. That's there. So voltages are all in place. What else could just kill this radio so badly? I feed a signal right into the antenna. I know what a strong and weak signal should do on a radio. So let's do that. Take my signal generator here. We're going to feed it right into the antenna. So the radio is currently tuned to where? Well, who knows? What, 800, something like that? 800, that's a moderate weak signal there, 800. Wow, is that where 680 is? I don't know. Oh, I do know. So 680 is that far up the band. Huh, that's right. It's possible. Yep. Let's go a little further up. A fairly quiet spot. So that's 30% modulation of 1000 hertz tone, volume full, signal level moderately low. With this up full, this radio should be screaming. It should be screaming out hiss or something. So it really is a problem here. So continuing with the sensitivity study though. Okay, so this is now a really strong signal. One level higher, and it's unnaturally strong. So this is as strong a signal as this thing could ever get from its own antenna. Probably stronger yet. Still no volume. Something seriously wrong here. Well, it's got these 3 existing capacitors. Could any one of those be somehow responsible? So the 0.02 I had found earlier in here. And we'll look for it later. I'll stare at it now. And then we have these ones, especially this great big thing here. What is it? Anyway, what are they? Great big guys. Okay, I'm going to study up and figure out what those guys are. Okay, so what I'm going to do is I'm going to try to feed the signal. I'm going to try to bypass some of the antenna stuff here and feed it more directly into the grid of the first tube, which is pin number 7. Pin number 7 is right there. Oh, this might go really loud here. Just if there's a, let me just turn that down a little bit. Pin number 7. Certainly don't hear anything screaming out at me. So what is going on at the, literally I'm putting the signal right on there. Pin number 5 would drive an IF signal through. I think the local oscillator is weak. I don't know if that's what, you know, I've always kind of wondered this. If the local oscillator is weak, does that make the radio weak? I think the answer might be yes. 12BE6, you can see why it tests the whole tube, because although it's doing two functions, it's really structured as one tube in there, one plate, one cathode, two grids. So can you see that in the camera there, that little curious right above right beside the L4, that little curly Q, unattached coil. That's probably down in here. Would somebody have removed it? Would somebody not knowing what they're doing found a little bit of wire there and thought that's not doing anything? You know, I've come across capacitors that amount to a piece of wire, two pieces of wire twisted, nothing more. And there are some strange things in these radios. How do I even know if this signal's low? Maybe it would actually tell me pin 1 in the 12BE6, pin 1 should have minus 8.5 volts on it with a star, indicates measure with a VTVM. Minus 8.5 on pin 1. Let's look at that. I don't think I looked at that. We can still use this meter, I'm pretty sure. We can always flip over if we have to. So pin 1, pin 1. Pin 1 is right here. I'm looking for a minus. Yeah, there it is right there. Minus 8.6. Hey, the radio got it. Hey, an open resistor or something. Something terrible like that. What open resistor would that be? So a little one right there. A little red, orange is this one here. I don't know what that would do. It's not likely to be defective. Because a big honking, big one, big honking. Where's that show up? What is it? It's a, let's find that, this big high wattage one. The high wattage ones run hot, stuff happens to them. So that's 27 with two zeros. Is that 2700? So a high wattage 2700. He's hunting. There it is. 2.7K between the filters. So this is part of the filtering system. You know, on other radios they put the speaker field coil in there. The cheaper ones they just throw a resistor in. So if this resistor is out of whack, then the voltages would be all wrong. They wouldn't be high down here, they'd be low. Just looking and saying, well, what if it's completely open? You'd have no plate voltage out here at all on the 50B5. There'd be no plate voltage on pin 5. I already checked that, didn't I? Well, let's go have another look. Ooh. Okay, pin 5. That's enough of a distraction to totally lose track of what I was just doing. Pin 5 on the 50B5. Pin 5. I'm sure I checked this. 1, 2, 3, 4, 5. Yeah, it's all there. 137. Oh, careful. 90. 137. Down here. Yeah, 128. Turns out to be 137. They should just make it all louder. Right. So I'm not really knowing what I'm doing. So let's go pin 5 of the first tube. That's the output of the first tube. And listen to it. Did I already do this? I maybe start doing things over and over here. Pin 5 on the first tube is where? 1, 2, 3, 4. Continuous wire to pin 6 is possible. So that means, yeah, pin 6. Pin 5 is, yeah, right. I'm going to try to get the pin 5 in there. Pin 5, what do we hear? Hold on here, I turned off my turn off the signal tracer for crying out loud. Just give it a chance to warm up. Now what am I doing here? I'm going to go on pin 5. I'm making a big mistake here. Pin 5, and I've got this thing set to audio. That's a big mistake. Let's set this to radio. Maybe that's what I did before. Radio, and then we want to listen. We could listen for 460, or we could listen for the actual should be able to listen to the output and use my signal tracer as a radio, and it should work. So to do that, put it like that. Let's see what we can get here, just so you can see what I'm up to. I didn't say it was a good radio. Okay, so it's not a good radio. But if we pick the output of the first tube, this thing gets a boost from the antenna. So that would be, again, pin 5 on the 12BE6, right down there. Right there. I would say absolutely nothing is there. Okay, it's just... So coming from the antenna, nothing. I'm in a bad way here. I'm in a bad way. Let's go back to pumping in a signal and tracing it through the radio. Nothing is showing up here. Okay, so we're gonna put that on the chassis. Put that in the external antenna. I do hear it. It just sounds like it's something is in cutoffs. Something is not right here at all. Let's listen now with the signal tracer. Turn this down. All we'll hear then is stuff from the signal tracer. And where do we want to start? So the radio is tuned. So if I go to the first grid, I'm already in a tuned area. So I have to tune the other radio to the same place this one's tuned. This one's not tuned to anything. Except I'm going to try the signal generator. Jim, you're going around in circles. You've been in here too long today. That's what it is. This thing is so weak. Full of heterodyne. Wow. Okay, so I'm blasting this radio with a powerful signal. It's almost nothing coming out of the speaker. So now listen to the same signal. Tune it in over here first. So we'll go right on the antenna connection. There it is. Sounds horrible, eh? Listen to that. And that's because I've got this where I've got this. I don't want this there. I want it the same as here. Let's try it now. Okay, that's better. That's better. The same thing with this ground. This might be the whole problem. Not really. Okay, here we go. We're ready now. The antenna sounds like this. That's the antenna. It's not very loud over there, is it? Now, same signal, just like that, should appear on the grid. Pin 7 of the first tube, pin 7. Much better. I don't know, could you see the sparks flying in there? So, okay, we got a good strong signal making it on a piece of wire into the radio. We're good there. And that was pin 7. And 12B6 tested good. Hey, let's listen to the oscillators. Let's think about this. If we're tuned to 770, the oscillator should be running at... Can't listen to it. There's no modulation in the oscillator. How can we tell how strong it is? Can you just take a voltage reading on it and put the scope on it? Could put the scope on it. I could actually read it then. I think that's what we got to do. Or just change the 12BE6 for crying out loud. I had other ones in my hand here. That's even easier. That's really easy. Let's try that. Okay, here we go with the 12BE6. I think it's NOS, new old stock. Holy, surely that's way beyond. The expectation was 1570, so you know, up around here. Beautiful. This is the guy. I'm putting this one in. And you will see what happens. Okay. Since the signal doesn't seem to be getting past the first two, it seems to make sense to try changing it. Okay, here you go. Lay him down because I think it's going to be blasting this time. He says, chuckling. Minus connection. Signal down. Lay down over here. Are you ready? About as ready as I can be. The day is the day is going by. Here we go. Oops. Try that again. So testing a tube doesn't necessarily prove the tube's condition. It's really, you just got to regard it as more information, extremely important information. But even though a tube shows good, it may not work in a radio and vice versa. That's my stomach growling there. Did you hear that? More radio. Okay, so still feeding in a signal. Pretty bad. Let me turn up the signal generator. Maybe the radio tuning has changed. Still no volume. There it is. That's no different. That is no different. So there should be a nice, clean, powerful 455 showing up here, a 460 rather, and I should be able to tune it in. And so I should be able to receive it, pick it up with this. Alright, 460. Okay. This is now tuned to 460. We want to get on the grid, the plate of the 12BE6 pin 5. Pin 5 was the one that was down this way, wasn't it? Pin 5. Let's count them again. Count them again. Don't rely on your memory. 7, 6, 5. This is the plate. Should be lots of sound. I can turn this down. Don't need that going. So you're going to hear the signal tracer. Maybe. Oh, that's lovely. Hey, nothing wrong with that. So that's the plate here. Haha, we got somewhere. So we know the signal's good here. So what we'll do, we'll travel down to the plate on the 12BA6, which is also pin 5, and see what's coming out of it. So, okay, 12BA6, plate is pin 5. 5, so 7, 6, 5. Okay, there's 5. Now this might be really loud. I'm going to turn down the signal tracer even lower. Was this pin 5? Okay, now let me turn the attenuator up because beautiful signal there. Okay, so that's lovely. Okay, my tracer's finally working somehow. So we got a good signal here. So we want to know what is arriving here. So that's pin 5 of the 12AT6. I think this is starting to get difficult to get at. Yeah, that's the one that's under here. Pin 5. Oh my gosh. So that'd be 1. Whoa. I think I see the gap. Okay, there's the gap. 5, 7, 6, 5. I can get at it. 5. What am I doing again? So we're listening right here. No, we're listening right here. Ooh. We listened here, it sounded fine. Now we're trying to hear here what is arriving at here. What is on this? Top of the 2.2 meg. Didn't see that. Pin 5. And that should be at 460 kilohertz. Pin 5. Pin 5. Oh, sounds fine. Okay, so now we know the problem is in the audio area, I think. So we'll go to the volume control, top of the volume control. Where'd it go? Okay, we're getting somewhere. Let's go back a bit. I just heard it on pin 5. Right there. Pin 5. Pin 5 is the grid into this 12 AT. So we can listen on pin 1 to hear what's being fed back to the triode side of the tube. Pin 1. No, I gotta put it right on the actual radio. Pin 1, hearing what the triode is, has got tickling its grid. Pin 1, am I right? Pin 1? Pin 1. Pin 1 is the guy. Right here. Hey, where are you? Oh, of course, on the wrong side of the volume control. Okay, hang on a sec here. That's easy, I can do it like this. Now, what are we hearing? The radio or the... Nothing on the tracer. Very, very, very weak. Very weak. You know what this is starting to look like? Open IF transformer. So the wire I was testing here was green. It says green. It's a green wire coming right out of here. Oh boy. The other, we should be able to hear it. Well, this is the top of the volume control. I already listened to that. The shorted capacitor right there. That's possible. C11. 220 picofarad. Well, if that's shorted, then we would see a short on the volume control would look like a short, and also it wouldn't have any effect. It wouldn't have any effect at all. So we're back here. Maybe if so we have B plus up here, so we know this is continuous. Oh, okay, so there could be a DC volt. We could take an ohm meter reading from here to here, and all we should see is this coil resistance. So that'd be from pin 5 to the top of the volume control. And we should see almost nothing. Well, this might have a fair bit of resistance in it. Let's try that. Is the coil record? Now, do I have to actually change that? So we're reading. So there's a direct attachment to, no there isn't, B minus, and this capacitor's in there. To the volume control. If I didn't, I could leave this connection, but I can't. Yeah, I got 2 leads in my hand. What am I going to do with them? We're going to guess that that's no more than 20,000 ohms. Shouldn't be anywhere near that, I would think, in this coil. So I want to get on 5 and top of the volume control. Okay, so 5 is here. Volume controls here or here. Well, wait a minute. I had this figured out before, but well, that's open at 200 at 20K. It's open. This one did a little action there. Which Okay, so I can see, actually, you know what I can see? I can see that there's a lead coming out of the hot tube. Coming out of the IF, going straight to the volume control. Coming out of the IF, straight to the volume control. So there's no question about which one that is. There's no question about it. No question. Yes, I know a little bit of French. If you're French, I'm insulting you though. Now, so that's definitely one end of this coil. The other end is 5 on the tube. What was that? Oh, this radio is off. It just farted at me. Did you hear that? This radio farts. Let's try that again. Open. Really? Really open? That's a negative. It's not going to help at all. How the heck do you actually... so where would that ever come from? So I'm looking at the circuit diagram. There's no explanation for why you would see a voltage here. So I'm doing this test wrong. Maybe they don't have the right... They don't have the right stuff. Let's see. 5 right through to the top of the volume control. 5 on the 12ET6. 12ET6, yeah, I'm not on 5 of the 12ET6. I'm on 5 of another 2. Duh. 5 of the 12ET6. Is it shorted? Ta-da-ta-da! Well, that's both good news and bad news. Good news that it's not shorted. That's not the right word. Is it open? Good news is it's not open circuit. We don't need to test the primary because we found the voltage. The radio's making sound all the way through anyway. Yeah, I'm kind of crazy. If this was open and not working at all being the operative word, tuning this wouldn't do anything. So we found signal here. Nothing over here. 2.2 meg, 4.7 meg. These are big resistors. Capacitor. I have to dig in each one of these components now and see what's going on with them. So I'm going to attend to that, but not on camera.